What we're going to do next is look for curves along which the solution u of xt is constant. Such curves are called characteristic curves. And the idea is that characteristic curves are curves that carry the signal. So if we go back to our advection initial value problem, so that looked like this guy. Recall that this has a solution given by the initial condition being translated at speed c. Okay. So the idea then is that the solution here, the density u, is constant along c given by x minus ct. So this is our characteristic curve right here. And if we go back to the picture that we looked at before, then you see that along these blue characteristic curves, which I've sketched here in blue, the function u, the surface generated by stitching all these curves together, remains constant. Okay, so let's consider a general advection equation with growth or decay. So we've got ut plus cux plus some growth term and some maybe sources or sinks. Okay, then this one, the solution for this one will grow at a rate a, so it's going to be shrinking if a is negative, and it's going to be moving or propagating rightward with speed c. All right, so what we're going to do then is we're going to move to or we're going to switch to a moving coordinate system. So we'll look at the new coordinates where c as a function of x and t is just going to be x minus ct, and our new time parameter is going to be tau, and it'll just be t. And we've referred to these as characteristic coordinates. So these are this is sort of like the appropriately adapted coordinate reference frame for this problem, because this problem is sort of on the move. So in the characteristic coordinates, we see that the function that we're looking for, our state variable, this guy becomes, let's give him a slightly different name, so we'll call him capital U. And so this will be u now of c plus c tau comma tau. And I got that one just from solving this guy here for x, to put it in. And this if we wanted to rewrite it the other way, this is the same thing as saying u of x minus ct comma t, which would be little u of xt. And so in particular, let's take this latter formulation here, and I'm going to differentiate this one with respect to time and space variables. So remember here, so here we've got uxt is capital U of, and then there's a c of xt and a tau of xt, and I want to differentiate this guy, so I'm going to need to use chain rule. So the partial with respect to x of this character is going to be, oh, sorry, I didn't mean to say that, bad pun, of this thing is u xi xi sub x plus u tau tau sub x. However, tau of x is independent of x, so when we take the derivative, that one goes away, and I'm just going to have u xi, and the derivative of xi with respect to x is just 1. Okay, so we've got that. Now we look at the time derivative, and so chain rule tells me this is going to be u xi time plus u tau time, and that'll be minus c u xi plus u tau. Okay, and so if I feed this all back into the original ut plus cux plus au equals f equation, this is going to become minus c u xi plus u tau, from that's my time derivative, and then I have plus c times my space derivative, and then I have plus a times the actual guy itself equals, and then I'm going to have some capital F, where f of xi tau is little f of xi plus c tau comma tau. Okay, and so let's see, so I've got some cancellation here between these terms, and I end up with u tau plus a u equals f. And so here all of a sudden we have obtained a first order linear ODE in tau. So by changing to the appropriate moving coordinate frame, the key point here is that the characteristic coordinates have the effect of transforming the operator dt plus c dx into the simpler operator d tau. Okay, and so you know how to solve a first order linear ODE. Use an integrating factor. So you could now solve the ODE by multiplying across by your multiplicative integrating factor e to the integral coefficient of linear term, which in this case is a dt, so that would just give you e to the a tau. Oh, sorry, I said t, I meant tau. Okay, and you could go ahead and solve I will spare you the details. And so this is the method of characteristics.